Now we're putting our rules all together and we're going to simplify expressions using all of the power rules that we've learned so far. Our essential question is the same as the last couple of days, so we'll get started. With exponent rules, there tends to be a lot of multiplying and dividing, which can be taken care of in either order in this case because of that division bar. So I see a couple of things that I can simplify all in one step. I'm going to flip this negative exponent to the denominator and make the exponent positive. I have a v to the 0 power, which simplifies to 1. When we multiply by 1, that doesn't change anything. So essentially, that term in our expression is going to disappear. So I've got my 2 left in the numerator, and in the denominator, I've got the 2v still in parentheses because it's being raised to the 3rd power. Next, I want to simplify that grouping symbol and distribute the cube through to both pieces. So I have v to the 4th times 2 cubed, which is 2 times 2, 4 times 2 is 8, and then distribute that cube to the v as well. Simplifying my fraction, 2 over 8 becomes 1 over 4. And in the denominator, I have multiplication. V to the 4th times v cubed means I add the exponents. Again, think about expanding them. You have 4 v's being multiplied together times another 3 v's for a total of 7 v's. Second problem, we have again a negative exponent, so I'm going to move that to the denominator and make that exponent positive. My 2n will stay in the numerator. In the denominator, I have this power, so I'm going to distribute that 2. 2 squared is 4, and 2 times 2 is 4. My power of a power rule. In the denominator, I'm going to multiply my n's together. So I still have 2n in the numerator. 4 is my coefficient in the denominator. And just like we saw in the last problem, n cubed times n to the 4th is n to the 7th. Simplifying my fraction, 2/4 simplifies to 1/2. And when I simplify my variables, notice how I have 1n in the numerator, which will cancel one of my 7n's in the denominator, leaving me with 6 n's in the denominator. So subtract the exponents when you have division, and your final answer goes wherever you had more variables to begin with. Whichever part of your expression had the higher exponent is where your simplified answer goes. Now we're going to take a look at simplifying with 2 variables. We're going to follow the same rules. Our first one, this time I have a negative in the denominator, so I'm going to move that up to the numerator, make that exponent positive. That x on the outside is going to stay an x. In the numerator, I'm going to distribute that 2 to all 3 pieces. So I have 2 squared is 4, x squared, and y cubed squared. I multiply when I have power of a power. Think PMA. Power means you will multiply those exponents. And my y squared left in the denominator. Simplifying my numerator, I have x cubed times x squared. So I'm going to add all of those exponents together to give me x to the 6th times y to the 6th. And I'm going to put my coefficient of 4 out front. In the denominator, I still have y squared. So now I'll cancel my y to the 6th with my y squared. So I have 4 x to the 6th. 2 of my y's will cancel, or I'm subtracting my exponents. 6 minus 2 is 4. Taking a look at example B, this time my negative exponent is being raised to a power, so I'm going to do my power rule before I flip that negative exponent. So I've got 2a to the 4th c squared, and then when I distribute that cube through my parentheses, I have to cube the negative 1 as well. And if you're confused because you don't see a negative 1, let me explain. -1 is the coefficient of my a to the -3 power. So -1 times -1 is +1, times another -1 is negative. And then my power of the power rule, I'll take my -3, multiply it by my +3, and get a -9, all over c to the 4th. Now I'm going to multiply my 2 by the -1 to get a -2, a to the 4th c squared, and I'll flip that a to the -9 to the denominator and make it positive with my c to the 4th. Simplifying my -2, I have nothing to combine it with. My a to the 4th over a to the 9th simplifies as a to the 5th in the denominator, because when I subtract the exponents I get 5, and I had more a's in the denominator to begin with. And same thing with my c's. I will cancel 2 of my c's, leaving me with 2 c's in the denominator because I had more c's in the denominator to begin with. Again, our division rule is subtracting those exponents. And finally, our error analysis. Remember, I will make at least one mistake on this, maybe more. It is your job to catch every mistake that is made. So first, I'm going to take this 2 and distribute it to everything inside the parentheses. So I get 2x to the 6th, y to the 5th, times x squared, y to the -2, all over x to the 9th, y to the -2. After that, I'm going to multiply my x's in the numerator, so I get x to the 8th. I'm going to multiply my y's in the numerator, so I get y to the -10. In the denominator, I don't have anything to multiply, so I have x to the 9th, y to the -2. After that, I need to flip my negative exponents, so I have 2x to the 8th, and the y to the -2 jumps to the numerator. In the denominator, I have x to the 9th, and my y to the -10 jumps to the denominator. Finally, I'm going to simplify, so I have 2x, because 9 minus 8 is 1, y to the 8th, because 10 minus 2 is 8. I made lots of mistakes in this one. I actually lost count of how many mistakes I made. So see if you can find all of the mistakes that I made.